Hello everyone and welcome. Today we're diving into one of the most fundamental sets of principles in object-oriented programming and software design, SOLID. These 5 design principles introduced by Robert C. Martin, also known as Uncle Bob, are crucial for creating maintainable, flexible, and understandable software systems. Adhering to SOLID principles can significantly improve the quality of your codebase, making it easier to extend and less prone to errors. Let's break down each principle. First up is the Single Responsibility Principle, or SRP. This principle states that a class should have only one reason to change. In simpler terms, a class should have only one job or responsibility. For example, consider a report class. If this class is responsible for both generating the report data and formatting it for printing, it violates SRP. If the report generation logic changes, the report class changes. If the printing format changes, the report class also changes. A better approach would be to separate these concerns into 2 distinct classes, one for report generation and another for report formatter. This separation ensures that each class is focused on a single task, reducing complexity and making the code easier to modify and test. Next, we have the Open/Closed Principle, or OCP. This principle suggests that software entities, classes, modules, functions, and so on, should be open for extension, but closed for modification. What does this mean? It means you should be able to add new functionality without altering existing code. A classic example is a shape drawing application. Instead of modifying a drawing class every time you introduce a new shape like a circle or triangle, you can design an iShape interface. New shapes would implement this interface, and the drawing class would work with the iShape interface, allowing new shapes to be added without changing the drawing class itself. OCP promotes stable and robust systems by preventing changes in one part of the code from affecting others. Moving on to the Liskov Substitution Principle, or LSP. This principle, named after Barbara Liskov, states that objects of a superclass should be replaceable with objects of its subclasses without breaking the application. In essence, if S is a subtype of T, then objects of type T may be replaced with objects of type S without altering any of the desirable properties of the program. A common violation of LSP is a rectangle and square hierarchy where square inherits from rectangle. If you set the width of a rectangle to 10 and height to 5, it works. But if you do the same for a square, which forces width and height to be equal, it behaves differently, breaking the expectation of the rectangle superclass. LSP ensures that inheritance is used correctly, leading to more predictable and reliable code. Fourth is the Interface Segregation Principle, or ISP. This principle advises that clients should not be forced to depend on interfaces they do not use. In other words, rather than one large, general-purpose interface, it's better to have many small, client-specific interfaces. Imagine a worker interface with methods like work, eat, and sleep. If you have a robot class that implements worker, it might not eat or sleep. ISP suggests breaking this into iWorkable, iEatable, and iSleepable interfaces. A human worker would implement all 3, while a robot would only implement iWorkable. ISP helps to reduce the impact of changes and promotes more cohesive and focused interfaces. Finally, we have the Dependency Inversion Principle, or DIP. This principle states that high-level modules should not depend on low-level modules. Both should depend on abstractions. Additionally, abstractions should not depend on details. Details should depend on abstractions. Consider a light switch controlling a light bulb. Without DIP, light switch directly depends on light bulb. With DIP, both light switch and light bulb depend on an iSwitchable interface. The light switch interacts with iSwitchable, and light bulb implements iSwitchable. DIP promotes loose coupling, making systems more flexible, testable, and resilient to change. And there you have it, the SOLID principles. Single responsibility, open/closed, Liskov substitution, interface segregation, and dependency inversion. By applying these principles, you can write cleaner, more robust, and more maintainable code, ultimately leading to better software design. If you found this explanation helpful, please like this video and subscribe to our channel for more content like this. Thanks for watching.